Hello everyone, how are you all? I hope you all are doing good. So we are back again with the next lecture of magnetic effects of current. So in the last lecture, we have learned two important electrical devices, yes, which are electric generator and electric motor. We have seen their working, we have seen their principle and how it actually performs the work. Yes, electric motor was converting electrical energy into mechanical energy. An electric generator was converting mechanical energy into electrical energy that we have learned in the last class. So we are here with the last topic of your chapter, magnetic effects of current. So we are basically going to see some practical based applications, which is known as domestic circuits. Yeah, whichever electric supply is coming into your homes, whatever circuits are involved in that we are going to see today. So we are basically going to study two topics in today's class, which are fuse. Second one is domestic circuit. Okay, so this is what you can see. These are basically called fuse, or you can say MCB, miniature circuit breaker. Miniature circuit breaker. This picture is showing that component which we are going to study, which is electric fuse. So see first what is electric fuse. So this picture you can see. In this picture there is a tube-like structure, small. Inside this you can see a thin wire. Inside this you can see a thin wire like this. Okay, so this is a setup which is known as fuse. This is a fuse which consists of a wire which is known as fuse wire. Which consists of a wire which is known as fuse wire, and fuse works on the principle of heating effect of current. Basically works on heating effect of current, which you studied in the last chapter, the previous chapter, that is heating effect of current. So what does actually fuse do? It is basically an electrical device or a device used in an electrical circuit, which is used for protecting humans as well as the appliances. It can protect human beings as well, and as well as the appliances present in the house or the domestic supply. Against what? Against overload. Against overload. So the fuse is a device. The definition goes as the fuse is a device used in an electrical circuit for protecting electrical device against overloads and short circuit. Okay, these terms we will see what they actually mean, that overloads and short circuit. So in the case of overload and short circuit, fuse is a device which is used to protect our electrical devices as well as the human body as well. So it is the simplest and cheapest device. This is important, that this construction of this fuse wire is simple and it is the cheapest device. So this is important, that it is the simplest and the cheapest devices used for interrupting an electrical circuit. Yes, interrupting means breaking. Basically do what? It breaks the circuit. It breaks the circuit under short circuit or excessive overload current magnitude. So what actually happens, suppose this is a path, suppose this one is present, or if I say this is a complete path, this is a road on which you have to go by your car. Okay, this is a complete path. Suppose the road has been broken by here. The road is missing from here somewhere now. So now in the first case, you were going smoothly on a road. Now if the road is not present in this portion, there is nothing, there is a deep valley. There is a deep valley. So would you be able to move through this road? No, you will not be able, because there is some braking. There is some braking in the road. This is the same function what fuse does. This is the same function what electric fuse does. What it does in the case of excessive overloads or under short circuit. In the case of excessive overload and the short circuit condition, it breaks the circuit or it melts itself. This wire is melted itself and breaks. Yes, this wire melts itself and breaks. So due to its breakage, suppose this is a fuse. Fuse is always connected before the main supply. This is fuse. This is this complete supply of your house. Okay, we will see how it actually goes. But yeah, the basic thing is that this is fuse. So in case of any short circuit or excessive loading, these fuse wire break. This fuse wire breaks, so there is no path for the current to flow. If this component is broken, this is a gap. Gap is created. So due to this gap, there is no flow of current. So your appliances have been saved or prevented from any damage. So this is the function of fuse wire. So if you can see, the fuse wire was melted. And the melting is due to something which is known as heating effect of current, that whenever a current passes through a resistor, whenever a current passes through a resistor, it will produce heat in that resistor. That is the concept. So according to you, what should be the melting point of fuse wire if it has to act as a circuit breaker? What is the basic purpose of fuse wire? It has to melt in case of excessive loads. If it does not melt, it will not serve the purpose. It will not break the circuit. So it has to melt to serve its purpose. It has to melt easily to serve its purpose. Can I say the wire of fuse should have low melting point? Wire of fuse or fuse wire should have low melting point. Why? Because if it is having high melting point, then it will not melt easily. And you are requiring to melt the fuse wire in case of excessive loading, so its melting point should be low so that it melts easily, and breaks the circuit. It melts easily and breaks the circuit. This is the case of electric fuse. That's what electric fuse does. Clear? It is an electrical component used in an electrical circuit for protecting electrical devices. Simplest and cheapest device, works as an interruption in electric circuits by breaking itself. So it should have low melting point, and it is based on heating effect of current. So I think this much points are clear. Okay. Now the next thing is domestic circuit, or you can say the supply which is coming to your house is arranged in how much way, or arranged in what way, that we are going to see under the topic domestic circuits. That we are going to see under the topic domestic circuits, that how actually electrical supply is taking place in your houses or homes. So before going into the domestic circuit supply, let's see, there are basically three types of wires in domestic circuit. One is earth wire, one is live wire, and one is neutral wire. Okay, one is earth wire, one is live wire, and one is neutral wire. Suppose what is happening, this is power station. So power supply is coming from the power station. It is coming into a substation near your home. It is coming into a substation into your homes, near to your homes. Then it is coming to your houses. Yes or no? So at the substation, actually the supply which is coming is always of two wires. One is live and second is neutral wires. Live wire and neutral wire. Live wire generally has a color red, as you can see in the domestic supply. Neutral wire will have a black or brown color. It can have a black or brown color. So what is live wire? Live wire actually carries the maximum, actually carries the current or supply. Live wires actually carries the supply. What is neutral wire? Neutral wire is that wire which is buried deep inside the earth. At a substation. Near to your house. So from there neutral wire is coming. Live wire is taking the electrical supply and it is coming to your house like this. So if you can see, this is our house. So at our house, whatever supply is coming consisting of two wires, live wire and neutral wire. So live wire is acting as a positive and negative wire is acting as a negative potential. Okay. So this is the case that two basic wires are there, live wire and neutral wire, which is coming or which are taking the electrical supply into our homes from the substation. Okay. So see, domestic electrical circuits are those circuits we receive power in our house. We basically receive power in our house through a main supply. Yes, this is a main supply which is commonly called as mains. It is supplied to overhead cables or underground cables. So there is a substation where main supply is there. From that main supply, the power reaches to our house with the help of overhead cables. Either they can be overhead cables connected by pillars or electric poles, or it will be underground. But in today's world, in most of the cases, the cables are underground only. No one prefers to take the cables overhead. So the most common ways in these days are the underground cables. So we are using underground cables to transfer the power. Clear? So as the power enters or the supply enters into your house, there is live wire and neutral wire. So first of all, it requires the fuse board. Fuse board consists of electric fuse, we have already seen. Fuse board consists of electric fuse, we have already seen. Okay. This is the main fuse present. Although fuse is present somewhere else, we will see also. So from the fuse board, it goes into the electric meter. From the fuse board, it goes into the electric meter, and then from electric meter, it goes into a distribution box. from where you will distribute the supply to individual rooms. Yes, you will use so there are some line cables. There are some line cables in the house which you are taking from electric meter. This is a distribution box. From the distribution box, line cables will transfer like this. Yeah. Now see, you are seeing these components. These are basically sockets. So these are 3 sockets shown in the diagram in 3 different places or 3 different rooms, you can say. Yeah. These are the 3 electrical sockets present in 3 different rooms. Yes, you can say. So you can see these are connected in parallel. You have already learned parallel combination. So you can see the potential difference across all the wires is 220 volts. So what we can say, the potential difference between live wire and neutral wire is 220 volts. The potential difference between live wire and neutral wire is 220 volts. And you can see these electric sockets are connected in parallel. So why they are connected in parallel? The advantage is that suppose in any condition the this electric socket damages, so it should not hamper the current supply in the remaining 2 sockets. That is the use of parallel combination, because if you apply series combination like this, suppose this is socket 1, 2 and 3. Suppose any socket breaks or damages, so it will hamper the supply of the entire circuit. Getting my point? Suppose this first electric socket damages, so the current will not be allowed to pass through it. And if the current is not allowed to pass through 1, then it will not allow to pass through 2 and 3 also, because all are in series. So we are not requiring to hamper the electric supply in case of damage of any electrical appliance. Yes, if any electrical appliance damage, we do not require we do not require that all the electrical appliances damages at the same time. That is the thing. So that's why the supply which is done in our house is parallel combination. And you see the live wire and neutral wire are coming. Live wire is red, neutral is brown, black. It is coming into your fuse board. From the fuse board, it is going into the electric meter, then into the distribution box, from where it is distributed into different places with the help of line cables. Now you can see a third wire also, which is green in color. This is the third wire, which is known as earth wire. This has a very important purpose. Earth wire is connected to every socket inside the house. You can see for every socket earth wire is connected, and that earth wire is directly going outside the house, and it is buried deep inside the earth. It is deep buried inside the earth. What is the purpose of earth wire? Earth wire is used to basically save our electrical appliances. Save our electrical appliances in case of overloading or short circuiting. So now 2 terms are there, overload and short circuit. So what is overload? Overload can occur due to 3 things. Overloading can occur due to 3 things. Either live wire and neutral wire touch each other. Either live wire and neutral wire touches each other. So what will happen? Why they are touching each other? Because their insulation cover may get damaged. Actually, they are covered with insulation cover. Wires, all the 3 wires, live, neutral and earth, are covered with insulation covers. So if their insulation cover breaks or damages, they will touch each other. So that touch will produce a overhead or overload condition, which is known as short circuiting. So in which a live wire and neutral wire touches each other. Okay. Second condition which can occur is that there is some excessive supply from the power station. Excessive voltage supply. Excessive voltage supply. So in that case also overload condition will occur. Yes. Or third case can be that you can connect if you connect more number of appliances from the same socket. If you connect more number of appliances from the same socket, then also overload condition can occur. So overload condition can occur in 3 cases. When you are connecting more appliances from a single socket, either the supply from the substation increases abruptly, or live wire or neutral wire touches each other. That is known as short circuiting. So in either of the 3 cases, the current will flow through the electrical appliance. So what earth wire will do? Earth wire will take all the excess current into the ground. Yes or no? Whatever excess current, or you can say leakage current, whatever leakage current or excess current is present, it will be taken by the earth wire into the ground or the earth, because earth has a maximum capacity, or you can say earth has a zero potential. Earth has a zero potential, and you know current always try to flow from high to low potential. So current will always try to flow into a zero potential body, that is earth. So this is the main use of earth wire, that if in case of any overload or in case of any short circuiting, whatever excess current or leakage current is present in the circuit is taken by the earth wire directly into the ground, and the humans which are touching the metallic objects or the electrical appliances, both are saved. Both are prevented or both are saved from any damage. So this is the basic function that electric wire do, earth wire do. And this process in which you are connecting the earth wire into the ground, this process is known as earthing or grounding. This process is known as earthing or grounding. So earthing or grounding is required for every house. Yes, during the construction of the house, if you ask your electrical appliance, if you ask your person whichever is associated with the electrical supply in your homes, then that person will say, I have done earthing. You should ask him, do you have earthing or do you done earthing or grounding? He will say, yeah, I have done earthing or grounding, because earthing and grounding is very necessary for every household. Fuse wire is again the same case. I have explained two words there, overload and short circuit. So I think the two words are clear. What is actually overload condition and short circuit condition? So in case of overloading and short circuiting, the temperature of this fuse wire increases due to the heating effect of current, and it melts. It melts and breaks down the circuit so that the circuit is saved. And if you can see, in every appliances fuse is present, or in every electrical socket fuse is present. Fuse is always connected to the live wire. Fuse is always connected to the live wire. Why? Fuse is always connected to the live wire. So why fuse is connected to the live wire? Because live wire is the main wire which is carrying the potential difference, all the potential of the electrical supply. So if any overload condition occur, that will occur through live wire. If any overload condition occur, that will occur through live wire. So that's why fuse is connected to the live wire. So if there is any overload, the wire will melt and break the circuit, and the appliances or the human beings are saved or prevented. Thumbs up, guys. Now clear what is electric fuse, how to do electric supply in a domestic circuit. We use three wires: earth wire, live wire, neutral wire. Neutral wire is connected to earth at a nearby substation. Live wire carries the potential of the supply. Earth wire is green in color, which is connected to the earth. It is basically connected to every electric socket, and from that socket it is connected to the earth. Yes. So what earth do? Earth has a zero potential, so all the excess current or all the leakage current will flow into the earth. That is the case. So I think this is clear. Okay. Now see, explain why there are two separate circuits. Now we are looking for some questions. Explain why there are two separate circuits, one for high power rating appliances and other for low power rating appliances. So high power rating appliances means which require high power. That is example, electric geyser. You can give electric geyser, heater. Yes, you can say coolers, air conditioners. These all are high power rating appliances. What are low power rating appliances? These can be fans, bulbs. Yes, these are some example of low power rating appliances. So the question is asking, explain why there are two separate circuits, one for high power rating appliances and other for low power rating appliances. So the answer is that two separate circuits are required. One is of 15 ampere and another one is of 5 ampere generally. One is of 5 ampere and another one is of 15 ampere. So 15 ampere current line is required for high power ratings appliances. Why? Because if you connect low power rating appliance with a high power rating appliance supply, suppose I will be required only 5 ampere for bulbs and fans, but I am giving it a 15 ampere supply. So that 15 ampere will act as an overload condition for these devices. Getting my point? This 15 ampere current line will act as an overload supply for the low power rating appliances. So maybe what will happen? Their fuse wire will melt and they will break the circuit. And you do not want any condition of breaking the circuit in normal circumstances, because there was no overhead supply actually. What is the case there? You have provided the excess supply which is not required by that device. So that's why two separate lines are required, one for high power rating appliances, that is 15 ampere, and other one is of 5 ampere appliances, that is low power rating appliances. So the answer is two separate circuits are formed in the domestic wiring, one for high power rating, other for low power rating. Circuit which draws heavy current, which means 15 amperes, are used for high power rating devices, just microwave oven, air conditioner, geyser, washing machine, etc. And lightning circuit means the circuit which draws small amount of current from the mains and used for low power rating devices such as bulb, tube light, fans, TV, computer. They have a power rating of 5 ampere. So this is the reason that if you do not supply different power supply, different current. So suppose the device require only 5 ampere current and you are providing it a 15 ampere line. So it will act as an overload condition for that device. So that we will not require. That way not required in the normal circumstances that the fuse wire will melt. Okay, now the case is clear. Okay, now see next question. In India, the potential difference between live wire and neutral wire is, so we already discussed in the domestic circuits that in India, the potential difference between live and neutral wire is 220 volt. 220 volt. That's why the supply is known as 220 volts. The supply which is coming into your houses in India are 220 volts. Done? Sorted? Okay. Now question number 3. Fuse are used in circuit 4. So basically the application of fuse has been asked, that why fuse are used in circuit. Equipment safety, yes. Human safety, yes. They are just saving you from the electric shock in the case of overload or short circuiting. None of the above? No. A and B are correct? Yes, both A and B are correct. So the correct answer should be option number 4, that both A and B are correct. So I hope these two topics, electric fuse and domestic supplies and domestic circuits or domestic electric circuits, if I say, these are clear to you. Yes or no? So what is electric fuse? Electric fuse is that component which saves your electrical appliances from any damage during overload or short circuiting. What is short circuiting? Whenever live wire touches neutral wire, then that condition is known as short circuiting. Clear? Then we have seen domestic electrical supply or domestic electrical circuits, which consist of 3 wires: live wire, neutral wire, and earth wire. Generally, live wire is of red color, neutral wire is of black color, and earth wire is of green color. So what is the application of earth wire? Earth wire is attached to every electrical socket or appliance, and that wire is directly goes into the earth. That wire directly goes into the earth via metal plate. Okay. So due to that metal plate, or this process is known as grounding. Suppose this is earth wire. This is connected to metal plate, and metal plate is buried deep inside the earth. So this is the grounding process or earthing process. Okay, this is earth wire. Okay, so we have seen these are parallel combination in domestic electric circuits. There is parallel combination. Potential difference in India 220 volt between live wire and neutral wire. There are 2 different lines, one for high power rating devices and one for low power rating devices. So I hope everything is clear. Yes. Okay then. So in case of any doubt, what you can do, you can refer to the Ask IITians website and post your doubts there, and that doubts will be resolved by our expert faculties there. Okay. So clear? Everything we have learned is clear? Okay. So thumbs up guys if you have enjoyed the session. Okay. Thank you. Stay safe and enjoy.